Hello everyone, doctor, my friend, and everybody. Now here we're gonna explain our project with presentation uh, with our group from group 6. And now let's begin.
Hello, Assalamualaikum. So today I will explain about section 1 and section 2. So basically the section 1 is auto mode control. So the explanation is this is the foundational section that enables or disable all automatic operation. So start at LD003. This instruction loads the current state on or off of the physical input 003 automatic master switch into the PLC internal processing register accumulator. So at the out W00, this instruction output state currently in the accumulator to the internal word bit W00 auto mode active flag. In simpler term, if the auto mode master switch 003 is turned on, then the auto mode active flag is will be set to on. So conversely, if the master switch is off, the W00 will be set on. If the master switch is off, the W00 will be off. This flag, which is the W00, act as a master enable for all subsequent automatic control logic. So when it off, when the 003 is off, then the W00 is off. When it's on, the W00 is on. Okay, so we go to the second section, which is the temperature control fan. So I will explain briefly, which is this section controls the ventilation fan based on temperature and the auto mode status. So start at LDW00, loads the state of the auto mode active flag W00. This ensure that the fan will be only controlled automatically if auto mode is enabled. And beside it is N00, perform a logical and operation between the state of W00 and the state of temperature high sensor. The fan will only turn on if both W00 auto mode active and 00 temperature high sensor are on. If either is off, the result of the N operation will be off. So lastly, at the out 100, uh, which is the fan control, is simply in simple term, the fan 100 will only turn on if the system is in auto mode and the temperature high sensor detect that the temperature has exceeded the set point. That's all from me for two sections. Thank you.
Alright, for the section 3, which are the third ring in the ladder diagram. Also for section 3, which are the soil moisture control, or what we call here the water pump. This section controls the water pump for irrigation. For load W0.0, load the auto mode active flag and the 001 perform a logical and operation between W0.00 and the soil moisture low sensor. So in result, for the output 10001, output the result to the water pump control 1001. In simple terms, the water pump will activate if the system is in auto mode and the soil moisture low sensor indicates that the soil is dry and needs watering. And for the fourth sections or the fourth ring, which are the light control, what control the grow lights, this section controls the supplemental grow lights. For the loads, which are called auto mode active flag and connected to the N002 performs a logical and operation between W0.0 and the light level low sensor. For the out 1002 outputs, the result to the grow lights control, which are 10002, or what in simpler terms, the grow lights will turn on if the system is in auto mode and the light level low sensor indicate insufficient natural light. That's all for me.
Okay, for the next section is 5 and 6. I will tell you about a manual override for water pump. So the explanation is this section approves a manual way to turn on the water pump, independent of the automatic control. This is a common safety or operational feature in automation system. So from the LD0004, load the state of the manual pump override button, or 10001 perform logic or operation between the state of the override button and the current state of the water pump control output is 10001. The OR instruction means that if either the manual override button is pressed or the water pump is already on, do the automatic logic 1001 is on. The result of the OR operation will be on. Output 1001. This combined result back to the water pump control. In the simpler, the water pump 10001 will turn on if the manual pump override button is pressed. Additionally, if the pump was already turned on, the automatic measure control or selection 3, back to selection 3, this selection ensure it stay on unless both the manual button is released and the auto condition is no longer met. This or logic ensure the pump stay on if any condition for it to be on is met. Okay, the last section is section 6, the system status indicator. Explanation. This is a simple section. Proof visual feedback to the user about the system operational mode. So, begin from the LDW0.00, or we can say load the state of the auto mode active flag. Out 1003 output is the state direct to the system status indicator. In simple terms, the system status indicator light will be on whenever the auto mode master switch is on indicator that automatic control system is active. Okay, that's it for me.
So the summarize is actually our automated greenhouse monitoring system using an Omron PLC is using a temperature, but we cannot use it for the CX programmer, so we just come up with this circuit. The automated greenhouse monitoring system using an Omron PLC is designed to regulate key environmental factors, temperature, humidity, soil moisture, and light to create optimal growing conditions for the plants. The system uses sensors like the HT11 or the HT22 or SHT for temperature and humidity, soil moisture probes, and LDR for light intensity. Based on real-time sensor data, the PLC control actuators such as fans, heaters, water pumps, and grow lights via relays or SSRs. For example, if the temperature exceeds 30 degrees Celsius, a fan is activated. If it falls below 20 degrees Celsius, a heater turns on. Similarly, the water pump is triggered when soil moisture drops below 30% and grow lights are switched on when ambient light is insufficient. The control logic is implemented in the Omron PLC using simple condition statements with provision for timers and hysteresis to prevent frequent switching of devices. An optimal HME can enhance usability by displaying live data, allowing user to set threshold and enabling manual overrides. This automation system improves plant health, conserve water, and reduce energy consumption through intelligent control, making it highly efficient and adaptable. It also offers a foundation for future upgrades to IoT or SCADA monitoring and control. That's it from our group 6 about the automated greenhouse monitoring system using an Omron PLC. So thank you very much for watching.
Thank you, everyone.